before, and then the code is the same, so I'm not gonna go over them again. So first I'm gonna go over drawings. So the drawings uses this color of the shape that's gonna be producing. So next we're gonna do the global set for color. It's gonna compare the register 0, and then it's gonna see if it's higher, then it will quit. So it's gonna go return address to program counter. The same thing for the second line. It's gonna quit. So it's gonna load the register 1, which is equals to 4 color. Basically, it's gonna pass the value of 4 color, and then it's gonna see if it's higher, register 1, and then do the value of register. If it's higher, if higher give register 0, then it'll give register 1 R1, and it will return the address. So pass the value of return address to program counter to avoid overwriting. And so basically we're gonna do set global graphics and go over this pretty much. It loads the register 1. It's gonna move the program counter from return address. So it's gonna go. It's gonna do the X and the Y pixels coordinates. It's gonna give R0 for the X and then R1 for Y, and then it's gonna do the address, the alias for the address, and then do comparison with Y height within the frame, and do the return the basically do return address to program counter when if it's quitting. It's gonna use high color, and also which is 32-bit color, and the full color into register 3, and then move the program counter to return address. And then in this code that we're adding the function, it's going to be using Bresenham's line algorithm. So it's gonna push register 4 to register 12, or the registry's value on a stack, pretty much, with the return address. So the X0 is going to use register 9 as an alias, and then X1 is going to use register 10, Y is going to use register 11, passing on, and Y1 is going to use register 12. So it's going to pass the value of X of 0.1 to R0, 0.2 to R1, and 0.1 to R0, and 0.2 to R1 for both X values and Y values. So it's going to use the alias again, and they'll compare the X0 with X1, and basically does a comparison here, the same thing, compares it Y0 to Y1, and that's the whole code of it, comparison that, and then it says test if it's equal, so it's going to test if X0 equals with X1, these two values right here, and then if it's not equal, or it will test if it's equal with Y0 and Y1, do the same thing, and they'll do pop equal the same from register 4 to register 12, including the program counter. So we'll delete the entire stack if either equal, and then I'll move on to registry 0 with the value of x, and registry 1 with the value of y, and do the same thing. So it's gonna pass. So it's gonna compare the error left shift and with error 2, and then do some more comparisons to it, and then delete the aliases with x0, and then those are the functions. Probably will delete all of them after it's done using them all. So now I'm gonna go into random s function. Random is gonna be using random. It's gonna generate random numbers, I guess, or yeah, random numbers. So it's gonna use registry 0 as an alias and registry 1, and then it will do pass the following value, and then do the multiply the two values and select the 3 at least significant bits for these two lines, and then we'll add together the two values. So it's gonna do randomly add register 0 a plus 73. So it's gonna randomly generate a plus 73, and then do this part. Move the return address and program counter. So it's gonna. I'm gonna go over the main.s file really quick. It's using a stack pointer, as you see. Then it's gonna set up the screen. The resolution 124 lines by 763, using register 0 and register 1. It's gonna use 16-bit color, high color. I mean, it's gonna test if it's not equal or if it's equal. So it's gonna test if it's equal, and if not equal, the LED will fail. The LED will flash and fail, so it's not gonna show on the TV. So now we're gonna move register 0, which is number 16. So that's gonna be 16-bit color. It's gonna do 1, register 1 as 1. So it's gonna use, okay. So it uses those values to compensate for something. I know 16. This one's coming out from this, but this one, it's coming out if it's gonna be testing if it's equal or not from this value, which is here. And then we set GPIO, and then error occurs. If no error, then it'd be info address bar. Address will be R4, and the same thing for I will move to R0. So it's gonna do earlier last random will be register 7. Last the X value will be using register 8 and register 9. The color will be using register 10. X and Y is going to be using register 6 and 5. So it's going to initialize at 0 all these functions. So it's going to pass register 0 of value of R7, which is going to use random function from 0 to 7, value of 7 register. So it's going to zero the value of color and add 1 to that value and get the next color and shift left. Now I'm gonna go a little bit of buffer, frame buffer.s file. I think it's similar. Yeah, so this is the code that was already done. I already explained in the last video, lesson 6. So I'm gonna move on now with the Ugarda tool. So let's go to my Ugarda tool. I'm gonna go to CMD. So CD C/Ugarda /bin, and now I'm gonna type in pymake. Now we're getting the build error, so I'm gonna go into this over again. I'm gonna close this file completely. Close. Unzip this. Yes to all. So we're gonna have new files again. Not to copy this whole thing. Everything. Now I'm gonna go delete the source folder only. And then copy this over. Sorry for taking too much time, but yeah, my computer's kinda slow a little bit too. Yes to all. So now I'm gonna go into pymake. Arm source which I need to generate. Go through, and now we type in pymake again. We get that error, so I'm gonna go and submit that error, which is make file that was modified. I'm gonna go into paste in my bin file again. Paste. Now go into pymake, and there we go, generate the image. I'll take out the card of my Raspberry Pi, so disconnect this adapter first, put this in. So it's gonna connect to the and I'm gonna take the image and send to boot G drive. Yes. Debian operating system. So there it is. So it's right here. 12 kilobytes. Thank you for watching.